Hey guys, today we're going to talk about rational exponents. Rational meaning it can be a fraction, so all the exponent rules that you learned in your last math class still apply when you're dealing with rational exponents. And we'll look at that in just a minute. But I want us to look at the general rule for rational exponents. And the general rule is if you have an index with a radical, say for example x, this number here is called an index. It could be a 3, a 4, or a 5. If there's nothing there, it's understood to be a 2. And we can rewrite that with a rational exponent, and that is going to be 1 over that index. So the n root of x is the same thing as x to the 1/n power. So let's take a look at some examples with some numbers. So if I take the square root of 36, we all know that that means 6. But if I only ask you to write it as a rational exponent, that's the same as saying 36 to the 1/2 power. 36 to the 1/2 power is the same as saying the square root of 36. There is a small little 2 right here with a square root. We don't generally write that little 2 there as my index. It's understood to be there. Let me get rid of that. Okay, so another example would be the cubed root of 64. Again, we are not simplifying. We are just looking at how to rewrite this. So this would be the same as saying 64 to the 1/3 power. 64 to the 1/3 power is the same as the cubed root of 64. Pretty simple. And we can keep doing this all day long. The 4th root of 16 is the same as saying 16 to the 1/4 power, which is the same as the 4th root of 16. So this is how you would need to rewrite. So if they're asking you to take a radical expression and rewrite it as a rational exponent, this is what they're asking you to do. We're not actually simplifying it. All right, moving on. Because I believe the worksheet that I gave you guys, you're going to take rational exponents and rewrite them as radicals. And of course, you could have some things with some parentheses. Let me back up here. Let me show you one with some parentheses here. So if I give you 2n inside the parentheses raised to the 1/3 power, that's the same as the cubed root of 2n. So the 2 and the n go underneath the radical. And of course, that's the same as putting it in parentheses. If I just put the 4th root of 5x, and then I write my answer, or my rewriting this as 5x to the 1/4, that is wrong, okay? Because you would need to have parentheses. So if you don't put the parentheses, that is wrong. If you put the parentheses, now that is correct. So just be very careful if you have multiple things under the radical. You need to hold them together with parentheses. Okay, moving on here, we are going to talk about simplifying. Simplifying expressions with rational exponents. All right, so what that means is now we can simply take some values like 216 to the 1/3 power, and you can actually put that into your calculator. So I'm going to pull up my calculator, and I'm going to put 216. I'm going to use the caret key, which is right below clear, and then I can type in that 1/3. And when I hit enter, I get 6 for my answer. It's easier to put the rational exponent into the calculator than it is to do the cubed root, 4th root, 5th root. If you wanted to put the radical into the calculator, you would have to go to math, and you can look at your options here. Option number 4 says the cubed root, so I would do the cubed root of 216, and you still get 6. So those mean the same thing. We just talked about how your index would be the denominator of that rational exponent. All right. Again, I think it's way easier to put the rational exponent into the calculator versus the radical, but that's just a personal preference. So to simplify this, this would be 6. So you can simply just cram this straight into your calculator. If you didn't have a calculator, then you would have to simplify this using a factor tree. And so I would have to find factors of 216, and I know it's even, so I can say 2 and 108. 108 is even, so I can say 2 and 54, 2 and 27, 3 and 9, 3 and 3. And because this is the same thing as a cubed root, instead of looking for pairs, remember with the square roots, we looked for pairs. With cubed roots, we would look for triplets. With the fourth root, you would look for quadruplets, 4 numbers that are the same. So here I'm looking for 3 numbers that match. So I have a group of 3 2s and I have a group of 3 3s. Well, I know 2 times 3 is 6. And of course, that's what we got with the calculator. Calculator's a lot simpler. And of course, I think most of these are going to be perfect little numbers, so you don't have to worry about getting a radical answer. But if you did get a radical answer, say for example, I have, I'm just going to make up a number here. Actually, I'm going to use my calculator to make up the number for me. We'll use 54. Say I had the cubed root of 54. That's 2 times 27, 3 times 9, and 3 times 3. I have my group of 3s that goes on the outside of the radical, and I have my leftover 2. So that would be the cubed root of 2. So that's what that would look like, simplified. If you put that in a calculator, you would have gotten a decimal. So if I put the cubed root of 54, that's not what I want. I want the cubed root. Where's my cubed root at? There it is. Of 54, I get a decimal. Okay, so you would have to simplify that with the factor tree. And because it's a cubed root, you're looking for 3 numbers that match. Does that make sense? I figure I was all over the place, but we know that this is the same thing as the cubed root of 216, and that's a tree that we can simplify with, which I just did over there. Okay, so cubed roots, square roots, whatever, put them in the calculator. Rational exponents is the way to go. It's easier to find in the calculator than it is to go through math and find the cubed root, the 4th root, 5th root. Just put it to the exponent. And of course, we know how to translate that to an exponent. It's just your index goes on the bottom of 1. Excuse me, I have like a frog in my throat. All right, so simplifying, I would put it in the calculator. No problems there. And I'll show you some that could be possibly on the worksheet here in a little bit. Now, not all the time is our numerator going to be 1, okay? So like if I had the cubed root of 32, we know that's the same thing as 32 to the 1/3 power. But what happens if I have maybe the 4th root of 50 and a squared on the outside? So what this means is that index, my index is this little tiny number here. My index goes on the bottom of my fraction, and my exponent goes on the top. So that would be 50 to the 2/4 power, which can be reduced to 50 to the 1/2 power. So that's what it would look like rewritten. Okay, so again, I can reverse this, and I could say 50 to the 2/4 power is the same as saying the 4th root of 50 squared. All right, so let's do another example. If I have 28 to the 2/3 power, okay, the denominator is your index, so that 3 is the index to my radical, and then the 28. Now you could write this as 28 squared underneath, or you can put parentheses around the whole thing and put the squared on the outside. They mean the same thing, it does not matter. And again, if I were given that radical, I could rewrite it the other way to give the rational exponent. Okay. All right, so little quick check for you. You can try these little problems here. I want you to rewrite. You're not simplifying them. I just want you to practice rewriting. So if you have the cubed root of 18, what would that be as a rational exponent? If you had x to the 1/4, what would that be as a radical? And if you had the fifth root, of 10, what would that be as a rational exponent? So pause the video, see what you would get for those three, and then unpause the video and see what you have if you got it correct. All right, so you are going to check your work and see what you got. You have 18 to the 1/3 power. You have the 4th root of x, and you have 10 to the 1/5 power. How did you do? Hopefully you did excellent. Okay, so now we're going to try some more rewrites. We're going to simplify this time. Let me get rid of all this. So I'm going to ask you to simplify these next problems. So you will cram it in your calculator, or if it doesn't give you a perfect number, you'll have to do that little factor tree and look for the correct groupings, either pairs, triplets, or quadruplets. All right, 64 to the 1/2 power. Tell me what that equals. 11 to the 1/2 times 11 to the 1/2. See what that equals. And 48 to the 1/4 power. See what that equals. So pause the video, give that a try, and see what you end up with. All right, so you have paused, you've tried these, so let's see what you have. 64 to the 1/2. I can use my calculator to see if that's perfect. So 64 caret 1/2, and I got 8. Because that is the same thing as saying the square root of 64. So hopefully you got 8. 11 to the 1/2 times 11 to the 1/2. Again, I can use my calculator. So 11 to the 1/2. You put that in there correctly. Jump down times 11 to the 1/2, and you get 11. And we'll talk about why that happens in a jiffy. So my answer here is 11. Now if I put 48 to the 1/4 in, I get a crazy decimal. So that means it's not perfect, so I'm going to have to use my tree. So this is the same thing as the 4th root of 48. So I can say 4 times 12, 2 times 2, 2 times 6, 2 times 3. I'm looking for 4 numbers that are the same. So I got 4 2s, and that leaves me with a leftover 3. So that would be 2 on the outside, because there's a group of 2s, 4th root of 3. So that is what 48 to the 1/4 power looks like. All right, so now let's take a look at some more examples whenever our numerator is not 1, because we have an exponent. Okay, so I'm going to clear this page, and I have, let me show you an example. Remember this, the denominator is your index. Of course, your base goes under, and then your exponent. And you remember, you can write that with or without parentheses. They mean the same thing. And this is fancy. This is the 7th root of x cubed. It looks very complicated, but it's not too terrible. So I want you guys to try these problems. Just rewrite them. Okay, don't try to simplify them or do anything crazy. Just rewrite this. Let's see here, x to the 2/5, write that as a radical. The 4th root of y cubed, write that as a rational exponent. And the 5th root of w to the 4th power, write that as a rational exponent. All right, so pause the video, give it a go. Unpause the video when you're done, and you can check your answers with me. So to rewrite this, my index is 5, because that's the denominator. Again, you can put the squared with the x, or you can put it around parentheses with the squared on the outside. They mean the same thing. I like the parentheses version, but it really does not matter. Let's see here. The next one, we're going to rewrite this as a rational exponent. So my cubed goes on top of my index. So that is the 3/4 power. And number 3, w is my base, 4 is my exponent, so that is my numerator, and my index is a 5. So that's my denominator. Pretty simple. So that is all you have to do or know about rational exponents. And then, of course, you must remember your rules with exponents that you learned last year. What do you mean, Miss Messer? Well, what I mean is if you have x cubed times x to the 4th, the rule is you add your exponents. So if you have rational exponents, you would just have to add your fractions. If I have x to the 4th power raised to the 2nd, you multiply your exponents. So that would be x to the 8th. So we have the rules that you should have learned from Math 1. You've got the product rule, you have your power rule, and another one is if you have negative exponents. Can't have negative exponents, so we move them to the bottom. So make sure you know these rules. These come from last year. And we have a quotient rule. And the quotient rule means you're going to, whoops, might help if I use the same letter here. Means you're going to subtract your exponents. So these are all things that you should have talked about last year. You got your product rule, your power, your product to a power product rule. One of those, I forget their names. It is important that you know their names. Negative exponent rule, and of course your quotient rule. And then of course anything to the 0 power equals 1. So this is from Math 1. And the only thing that we're going to do is we're going to put exponents on them. So for example, you have a worksheet where you have to simplify using the exponent rules. I'm just going to pick one from this worksheet. X squared, y to the 1/2, raise that to the 7/4 power. So that's using this rule here. So you're going to multiply your exponents together. So when I multiply my exponents, I'm going to say 7/4 times 2. So 7/4 times 2 is 14/4, and we'll reduce that in a minute. Multiply 1/2 and 7/4, that gives you 7/8. If you can't at all possible, make sure you reduce your fractions. So this would be 7/2, and this would be 7/8 would stay, and that would be your answer. Okay, so you just have to use the same rules as you learned last year, and just make sure that you multiply when you're distributing. I always call this the distributing because there's parentheses. If you're multiplying, you add. Negatives move to the bottom. If you are dividing, you subtract. Anything to the 0 power equals 1. So if you don't remember those rules, just let me know and I can go in depth a little bit more with that. But you should know if you're multiplying, add your exponents. Parentheses, multiply. Negatives, move. Division, subtract. All right, so on the worksheet that you guys have, the first 5 questions you're going to rewrite in radical form, which we've already talked about. Review the video if you've forgotten. Write the expression in exponential form, that's numbers 6 through 10. Simplifying, okay, that's just using these exponent rules along with whole numbers. Put the whole number in the calculator with that exponent. And then 18 through 25 is what I just did over here using these exponent rules. All right, again, if you guys have questions, please remember to email me or message me, and I'll see what I can do to help you. And I hope you guys have a great day.